Okay, question 6. We consider two variables, x1 and x2. By the way, right. So we are starting from this assumption, right? Everything is demeaned, which simplifies the problem a lot. The main problem here is x2 is okay, but x1 may not be exogenous. That is the problem. Okay, everything as this is full rank assumptions, so they are not a big problem. So assume that delta is not zero. Find a parameter value that is observational equivalent but different from the truth. So this means it is actually no different, right, from the earlier examples, earlier questions, right? So suppose that delta zero is the true correlation between x1 and u, and then it will identify, if you knew delta 0, you are going to get beta 1 0 and beta 2 0. Now I will choose any delta tilde that is different from delta 0, and then you will be able to find sorry, so what I meant is you will be able to find different values, observational equivalent, but different values of beta 1 and beta 2. The idea is the same. I'm going to define ui tilde. So by changing the random variable, this error term, ui tilde will be ui plus delta tilde minus delta 0 times x1i divided by variance of x1i. Right? Idea is exactly the same. We have done this earlier, so then you can show that this new error term will give you covariance delta tilde. So this is how we are, what we intended. And then to make it this way, I am going to define beta 1 tilde as beta 1 0 minus delta tilde minus delta 0 x over variance of x1i. Okay, however, beta 2 tilde is the same, right? So then, as you see, beta 1 0 x1i plus beta 2 0 x2i plus u can be written as beta 1 0 minus delta variance x1i plus beta 2 0 x2i plus ui plus this much. I subtract and add the same thing. Okay, so equality does not change, but as you see, this is beta 1 tilde, and this is ui tilde, and this is beta 2 tilde. So as we intended, we get the same observational distribution with satisfying all the assumptions. Okay, the next part. If you assume the endogenous variable was actually exogenous, it's a misspecification, derive the bias. Okay, so if you assume, you are assuming this, then you are going to get beta 1 0 beta 2 0 as expectation of xi transpose inverse xi yi. Okay, so again, this is estimand, and this is your parameter. I am going to recalculate this part, right? To do that, let me do some algebra. So expectation xi transpose equals expectation x1 squared, expectation x1 x2, expectation x1 x2 again, expectation x2i squared. Okay, and its inverse is right? The determinant in the denominator, and you get expectation x2 squared minus expectation x1, x2 minus expectation x1, x2, expectation x1 squared. This is the inverse of the 2 by 2. So, and you know, this is covariance. So, oh, no. I'm sorry about that. It's not covariance. So, if you continue, then expectation xi transpose inverse times expectation xi yi equals determinant. I will just leave it as determinant. Expectation x1 squared, expectation x1 x2, expectation minus x1 x2, expectation sorry again, expectation x. These times, right? I'm sorry, I made many mistakes here. X1, x2, y, right? We are going to calculate that. We are going to calculate that here. It's a lot of work. 1 over determinant times expectation x2 squared times expectation x1y minus expectation x1 x2 times expectation x2y. Okay. I think it is not a good idea. Oh, it's not a good idea. I'm sorry about that. Let me erase all these. I was very stupid, right? So a better way is from here, as using the general form, xi here, xi transpose beta 0 plus ui. I will just go this way. Okay, so starting from here is much better, right? So xi ui is expectation of x1 ui and expectation x2 I ui. It is 2 by 1 vector, and the first one is raw, but the second one is 0, right? That is a simplification. Then now you can calculate. Now rewrite. This is the bias. We already have the expression for the bias. So expectation xi x transpose inverse times expectation xi ui is 1 over determinant times expectation x2 squared, expectation x1 squared here, minus expectation x1 x2, x1 x2 times raw and 0, right? Let's do this. This is much easier to calculate. That equals 1 over determinant times expectation x2 squared times raw. That is what we get here, minus x1 x2 times raw. So, right, when you multiply like this, you get this form, right? Determinant is just non-zero. That means we have misspecification bias that is proportional to raw, but also what is interesting here is x2 was okay. x2 was exogenous, but beta 2 still has misspecification bias, right? The problem was about x1, but x2 also, the coefficient of x2 also has a problem, and the only way to block that is zero covariance. If covariance between x1 and x2 was 0, then beta 2 would be safe. Otherwise, beta 2 is affected. Okay, this is part B. And let's finish with part C. We introduce instrumental variable, and there are many ways to utilize the instrumental variable. You may use moment condition approach, or you may use fitted value approach. But like I prefer moment condition approach. It is more generalizable. But fitted value approach, when you do that, you have to think about, say, alpha, so x1 equals things like this. So you have to include all the exogenous variables on the right hand side of the fitted value. But I am going to show you the moment condition approach that is based on this and this. So rewrite this. I will write this as expectation of zi x2I times yi minus xi transpose beta 0 should be 0. That's what we get. Okay, and this is the linear form because we can write it as expectation zi yi expectation x2I yi equals expectation zi x2I times xi transpose, where xi is x1 and x2, times beta. Okay, so that means if this is a 2 by 2 matrix, if this 2 by 2 matrix is invariable, then beta is identified, right? Let's think about that. The 2 by 2 matrix is expectation z x1I, expectation z x2I, expectation x2I x1I, expectation x2I squared, right? We need to check if this this is invariable. If that is invariable, then that is this is the identification. That is beta. Oh, it's not definition. This is beta 0, right? Lastly, let me check the invariability, right? The determinant of the 2 by 2 matrix was zi x1I minus expectation z2 x2I times x1I x2I. So this should be 0. As long as it is not 0, then we get the identification.